Hey guys, today in this video we're going to talk about the mole. We've already gone through the notes on the mole, so this is just a review of what we talked about in class before spring break. But in the notes about the mole, we learned first that the mole is just a way of counting out things. It's like saying a dozen or a pair or a ream or something like that. But 6.02 times 10 to the 23rd of whatever you're counting is the number of what we're counting in a sample in chemistry. So if you have 6.02 times 10 to the 23rd, it's called a mole. We use it to measure out particles. So with your 6.02 times 10 to the 23rd particles is equal to 1 mole, we first need to define what a particle actually means. So if we have a particle here, you have to look at the type of compound that you're dealing with in the math problem itself. You either have a single element or you have some type of a compound, one of these two. If you just have a single element on the periodic table, that's going to be called an atom. So if you have just, go to my periodic table here, if we have just manganese, or if we have just zinc, or we have just magnesium, just beryllium, just one of any of those things, it's considered to be an atom. They won't have any numbers with them, just the element itself. Now, when you have numbers, or if you have more than one element that's there that's chemically combined together, it's either going to be ionic or covalent. Just as a refresher there, covalent is only made up of nonmetals. And then an ionic compound has a metal paired up with a nonmetal. Or you might see a polyatomic ion there. Remember, those are found in the parentheses. Nonmetals are just elements that are found on that corner of the periodic table to the right. But if you have a metal written first, that means it's ionic. So if you have a covalent particle, those are actually called molecules. And then if you have a particle that's ionic, meaning it has a metal in it, they have a transfer of electrons, that's called a formula unit. So looking at a list like this, you would just have to identify what type of particle you have. Tin is just Sn on the periodic table. There's no numbers or anything with it, so that would be an atom. MgCl2, magnesium, is over here on the periodic table. It's a metal. So because magnesium is a metal, chlorine's a nonmetal that's ionic, so this makes it a formula unit. Hg is again just a single element on the periodic table, so that's called an atom. I2, that's two iodines chemically combined together. So if we have two iodines chemically combined together, that's called a molecule. Iodine is a nonmetal, so you have two nonmetals present. This one we have three nonmetals present, carbon and two oxygens. So because this is only nonmetals, this is a molecule as well. And then the last one on my list here, I have Fe and then CO3. Fe is a metal. CO3 is carbonate. So that's a polyatomic ion. So this one's called a formula unit. So what we did with this knowledge first was we actually used the number of particles in 1 mole. So where it says particles, you're going to be using either atom, or you're going to be using molecule, or going to be using formula unit, just depending on what you have present. But we used this conversion factor first in order to do our first type of math problem, which is just between particles and moles, or moles to particles. This one just has molecules for my particles. This might say formula units, it might say atoms, whatever it is, but you're going between moles and a type of particle. So this first problem that I have, it says that we have 5.7 times 10 to the 22nd molecules, and we want to know how many moles that is equal to. So you always start with the number that's given in the question, 5.7 times 10 to the 22nd molecules. In order to get rid of the unit molecule, you have to slide molecule in the bottom for it to cancel. My conversion factor says that 1 mole is equal to 6.02 times 10 to the 23rd molecules in this case. So because I have molecules on top, the molecules has to go in the bottom. So I'm going to take this whole thing and put it in the bottom down here, 6.02. times 10 to the 23rd molecules. And that's equal to 1 mole. So now to solve this problem, I'm going to get my calculator. And remember with your calculator, if you're using like an iPhone or your smartphone, you're going to have to turn it to the side in order to get to the EE button, but that's your exponent. On this one, it's right here, it's EE. If the ones that we have in the classroom, again, it's EE, it's above the 7. So it's in the same place as the one that you're used to using. This one, you're going to take 5.7 times 10 to the 22nd times 1, which you don't have to worry about because times 1 is just the same number, divided by Avogadro's number. So I'm going to take 5.7 second E, and then it was 22, divided by 6.02 E 23. I did something wrong. There we go. Rounding to 2 numbers, like we still need all the zeros that are there, but I have 0.095. So I showed my work, I have my correct answer, and in the unit here, molecules cancels because that's on top and bottom, so then I'm just going to write the word mole for my units. So those are the first problems that we did. The second type of problem that we looked at used the molar mass. The molar mass is the mass of 1 mole of whatever you're counting. So we have 1 mole is equal to however many grams it is from the periodic table. That's the conversion factor we have to use in order to do the math problems. So this is just some practice getting that molar mass. So when we look at the periodic table, like I'm going to do this one that says aluminum first. When I look at my periodic table over here, aluminum's mass right there is 26.98. We always round to 2 decimal places. So with my molar mass that I have, I would just have 1 mole is equal to 26.98 grams. Now, if I have more than one element like BRF3, I would need to take the mass of bromine. Ooh, sorry, I kind of fell off the paper there. I'm going to take the mass of bromine plus fluorine plus fluorine plus fluorine. Or if you just want to type it in your calculator as bromine plus fluorine 3 times. But you're going to have to find the mass of those elements on the periodic table itself. So again, I'm going to get my calculator. When I look up the mass of bromine on the periodic table, it's 79.90. There's only one of them, so I just add that one once. And then fluorine is 18.9998, so that's going to round up to 19. I'm going to do that 3 times. So 136.90 for my molar mass of BRF3, so we have 1 mole, is equal to 136.90 grams. If you have parentheses like we do on this one, it's a pretty big little compound here, you would have to find the mass of each of the elements. Gallium is 69.72. Carbon is 12.01. Hydrogen is 1.01. And then oxygen is 16. Now I need to multiply them. Gallium, there's only 1, so I'm going to take that times 1, which you don't have to worry about. Carbon, there's 2 times 3, that's 6. So I'm going to have to multiply that one out to get my number there. There's 9 hydrogen, 3 times 3. I'm going to take that times 9. And then 16, that's oxygen, 2 times 3 is 6. So I'm going to have to do all that and add it together. So I have 69.72 plus 12.01 times 6 plus 1.01 times 9 plus 16 times 6. And I'm going to get, for my answer here, 246.87 grams for the mass of 1 mole. So with my answer here, again, we're going to write it like a conversion factor. So you put the mass of everything added together, and then that's the mass of 1 mole. Now we use this conversion factor in order to do math problems like this one. This one says how many moles are in 45.9 grams of sodium carbonate. Now sodium carbonate is Na2CO3. In order to go from grams to moles, I'm going to use that molar mass conversion. So 1 mole is equal to however many grams this guy is equal to. So the mass of carbon, I'm going to start with sodium, 22.99 times 2, plus my 1 carbon, which is 12.01, plus my 3 oxygen. And that's going to give me 105.99 grams. So 1 mole is equal to 105.99 grams. You're just going to set it up like this, 45.9. To get rid of grams, grams has to go in the bottom to cancel. So the grams right here is 105.99, and that's the mass of 1 mole. So again, on this one, I'm going to end up dividing 45.9 divided by 105.99, and we get 0.43 moles. I'm using the unit mole because that's what it's asking for, but grams on top and bottom cancel, so that's going to leave me with that mole. So both of those are one-step problems where you're only using one of the conversion factors at a time. We also did conversion factors where you're using both of them. I'm going to write down both of the conversion factors just so we have them handy. So we have 1 mole is equal to your molar mass in grams from the periodic table. We also have 1 mole is equal to 6.02 times 10 to the 23rd particles. Now in this case, my particle is going to be a molecule because that's what's given in the question. So it says convert 3.42 grams of ammonia into molecules. So I'm starting with grams here, and I need to end down here with particles. So I need to use both of my conversion factors in order to do this math problem. But first, I have to find the molar mass to plug in right there. So I'm going to take the mass of nitrogen, which is 14.01. I have 3 hydrogens, which is 3.03. So the mass that I'm going to plug in right here is 17.04 grams for the mass of 1 mole. Again, start with the number that's given in the question, 3.42 grams. Because grams is on top, grams has to go in the bottom to cancel. Always equal to 1 mole. So I'm going to take my 17.4 grams, 0.04 grams, gram on top and bottom, that cancels, that leaves me with moles. It's asking for molecules, so I need to take this one step further. 1 mole is equal to 6.02 times 10 to the 23rd molecules. So moles cancels, that leaves me with molecules, which is what the question's asking for. So to do my math here, I'm going to get my calculator out, and I'm going to put 3.42 times Avogadro's number, 6.02 times 10 to the 23rd, divided by 17.04. Again, rounding to 2 decimal places is all that you need. So 1.20 times 10 to the 23rd. Nope, that's 1.21. Sorry, I didn't see that 8 next door. 1.21 times 10 to the 23rd molecules. So if you have a 2-step problem, you're going to have mass, and you're going to have to go to particles, or you're going to have particles, and you're going to have to go to mass. Now, finally, the last type of problem that we did is the percent composition. To find the percent composition, you're going to take the total element mass, and you're going to divide that by the molar mass. And then that's times 100. So the molar mass is the mass of the whole compound. Nope, that's a 3. So Al2CO3, 3. I'm going to have to find the mass of this whole thing and plug it in right there. And then I want the mass of carbon, so I'm going to put just my 3 carbons on top. So I have 3 carbons there, and then the mass of this whole thing on the bottom. So carbon, oops, I didn't need that one. Carbon has a mass of 12.01. So if we have 12.01 times 3, that's 36.03. I'm going to keep adding to that my 2 aluminum, so plus 26.98 times 2, plus my 9 oxygen, so 16 times 9. That gives me a total mass of 233.99 grams. And then I take that times 100. So to get the percent composition, we're going to take 36.03 divided by 233.99, and then times 100. 2 decimal places is all you need. So 15.40% is going to be my answer for that one. So that was the unit in, I don't know, hopefully less than 15 minutes. Let me know if you guys have any questions on anything, and I'll be dropping in a review today as well. But I just wanted to give you something first to start with if you wanted to watch the video.